So what does it mean for a function to be increasing, decreasing, and constant? Well, here's our textbook definition. A function f of x is said to be increasing on an interval if for any x1 and x2 in the interval where x1 is less than x2, f of x1 is less than f of x2. Well, what does that actually mean? Let's come up with a little more simple definition here. As we look at the graph, as the graph goes from left to right, the graph is going to be going up. The graph goes up as it moves from left to right. That means that the function is increasing. Remember, just like you would read text on a page from left to right, you want to read a graph from left to right as well. If the graph is going up as we move from left to right, the function is said to be increasing. A function f of x is said to be decreasing on an interval if for any x1 and x2 in the interval where x1 is less than x2, f of x1 is greater than f of x2. Again, to simplify this definition, the graph goes down as it moves from left to right. Still, always reading the graph from left to right. If it's going down, that means that it is decreasing. And finally, we have constant. A function f of x is said to be constant on an interval if for any x1 and x2 in the interval where x1 is less than x2, f of x1 is equal to f of x2. A function is constant if the slope of the graph is 0 as it moves from left to right. What we are going to be dealing with is some horizontal part of a line. Let's see if we can look at some examples here, look at some graphs, and determine the intervals over which the function is increasing, decreasing, and constant. Now, a couple things. When you see the word interval, always think about interval notation. This is telling you how you should write your answers. Our answers should be in interval notation. We're talking about intervals, and more specifically, this means over what values of x. When you see intervals, think over what values of x. Write that down in your notes right now if you're watching this. Intervals means over what values of x. So when we're trying to figure out where the function is increasing, this is saying over what values of x is the function increasing? Well, where is the graph going up as we move from left to right? This portion of the graph right here. And over what values of x does that include? Well, that includes values of x from x equals 5, all right, from x equals 5 to x equals infinity. So we're going to write that answer in interval notation. The interval is from 5 to infinity. Now notice we have parentheses around both sides. The reason being is that you can't technically be increasing, decreasing, or constant at an endpoint. All right, so whenever you are writing down intervals for increasing, decreasing, and constant, it's always going to be parentheses. You will never use a bracket. Again, it can't be increasing, decreasing, or constant at an endpoint. All right, decreasing. That means that the graph is going down as we move from left to right. Well, where is the graph going down as we move from left to right? In this portion of the graph right here. Over what x values does that occur? Well, that occurs between x equals -4 and x equals -2. So that means our answer for decreasing would be parentheses -4, comma -2 with parentheses. Again, the endpoints here can never be included. We're always going to use parentheses. And finally, where is the function constant? Constant means our slope is 0. We are dealing with a horizontal line. And recognize that there are two different parts here where the function is constant. Right? Over what values of x is the function constant? From x equals -9. So between x equals -9 and x equals -4. Right? Between -9 and -4. It is also constant between -2, x equals -2, and x equals 5. So our answer is going to be parentheses -9 comma -4. That's this first portion here, and -2 comma +5. That's the second portion. Again, always use parentheses when we are talking about intervals for increasing, decreasing, and constant. All right. Use a graphing utility to graph the function. Determine the intervals. And again, when you see the word interval, think about interval notation. Recognize that means over what values of x, okay, is the function increasing, decreasing, and constant. So graph this in your calculator. F of x is equal to x squared plus x plus 1 divided by x plus 1. Remember that when you're plugging these fractions into your calculator, it's really important that you include parentheses around the entire numerator and around the entire denominator. Doing so will result in a graph that looks like this. So we need to figure out where is the function increasing, decreasing, and constant. Again, increasing means that the graph is going up as we move from left to right. Well, where is it going up as we move from left to right? In this region right here, and in this region right here. To answer the question, we need to think, over what values of x is the graph going up? Well, this would be from negative infinity, right? This graph is going to continue to go to the left, all right? From negative infinity to x equals negative 2, right? That's going to be the first part of our solution. Parentheses, negative infinity, negative 2 with parentheses, all right? It is increasing between negative infinity and negative 2. Notice that after negative 2, the graph starts to go down, okay? Where else is the graph going up as we move from left to right? Well, here at x equals 0 to x equals positive infinity. The graph continues to go up as we move from left to right. Therefore, our answer for increasing is going to be values of x between negative infinity and negative 2 and between 0 and positive infinity. Again, parentheses around the outside of all of that. Okay, what about decreasing? Decreasing means that the graph is going down as we move from left to right. Well, notice here at x equals negative 2, the function starts to go downward. Now, at x equals negative 1, what's happening here? There is actually a vertical asymptote at x equals negative 1. Okay? Hopefully you guys have seen these vertical asymptotes before. We'll talk more about them later on. But that means that the function actually can't equal negative 1. Negative 1 does not work when I go to plug it in. So it is decreasing from negative 2 to negative 1, right? Between negative 2 and negative 1. Similarly, up here, notice that the graph is also going down as we move from left to right. Over what values of x is it doing that? Well, from values of x from negative 1 to 0. So our function is decreasing on the intervals from negative 2 to negative 1. So that's parentheses negative 2 comma negative 1 and parentheses negative 1 comma 0. Again, over what values of x is the function going down? And finally, intervals where our function is constant. Is there anywhere on this graph where we have a horizontal line? No, there is not. So in this case, the constant part does not apply. There you have intervals for increasing, decreasing, and constant. Remember, whenever you write your answer, use interval notation. It's always going to be parentheses when we are talking about intervals for increasing, decreasing, and constant, okay, because the endpoints can never be included. All right, and make note that when it says find the intervals, it's asking you over what x values, over what values of x. Nothing to do with the y values, so don't worry about the y values. Think over what values of x is the graph going up, over what values of x is the graph going down, over what values of x is the graph constant.